Hello and welcome to Yahoo's Hack Together Hackathon. My name is Aaron, and today I'm going to be walking you through the Elide framework. So in this presentation, I'm going to tell you about what Elide is and what it can do for you. We'll walk through a quick example project. I'll talk about the various modules that are in the Elide framework and how to build and test them. We'll go through a very high-level design for all the components in Elide, and then we'll talk about next steps for how to get started with the hackathon. So first and foremost, what is Elide? Elide is a framework for building APIs, and it is a model-driven framework, which means that the way you build your API is you define a data model and then expose it through a web service. And you build your model typically using the JVM language of your choice. You're basically defining classes. Elide's APIs use standards like JSON-API and GraphQL. These are very mobile-friendly and application-friendly APIs that allow the developer to be in complete control of the payloads and responses that are being transmitted between the application and the backend. The APIs are also what you call a graph API, which basically means that your model or the set of models you want to expose can be related to one another. And so in a single round trip request from the application, you can do all kinds of manipulations on the models or fetch all kinds of different data, and the client has complete control over that in a single round trip. The APIs are fully featured. They support complex filtering expressions, sorting, pagination, and text search. And they're fully customizable, which means you can extend your API with custom business rules, security checks, and also validation rules simply by decorating the data model. And Elide is 100% open source. Now, there are 4 different facets of Elide that are important to know about. First is that there are 2 different kinds of APIs, JSON-API and GraphQL. And you might wonder, why does Elide support 2 different APIs? So JSON-API and GraphQL are both very similar. They're both graph APIs, but they also have some differences, and so you might prefer one over the other depending on your circumstance. JSON-API is a REST API, and so it's actually very simple to understand. And most people, when they see it, it's sort of very intuitive and they'll know how to use it. Because it is REST and it's based on HTTP standards, it's very easy to put limits on it on the edge. Like, for example, if you wanted to lock down certain routes, you could do that very simply without having to introspect inside the HTTP payload. And it's also easy to cache. Now, GraphQL, on the other hand, is very powerful. And so some of that power, it can do things more than you can with JSON API. For example, attributes in your model can take parameters. So it's very easy to write functions. There's also some more advanced modeling techniques that you can do things with unions and inheritance and so forth. But it has a steeper learning curve. It's not as intuitive. It's not as easy. But on the flip side, there's a phenomenal community around GraphQL and lots of great tools and client libraries that you can leverage. And so GraphQL tends to work really well when you're just building an application, but not exposing an API for third-party integrations. The other 2 facets about Elide is that it provides the 2 most common abstractions that you see today when you're building an application. The first is CRUD. CRUD stands for create, read, update, and delete. And it's a sort of a universal pattern when you're building an application that needs to read and write data from a database. CRUD also works really well, maps really well to REST. The other one is analytics. And analytics is when you want to explore data by aggregating some numeric data, which are typically called measures by one or more dimensions. And dimensions could be things like demographics, like age and gender. So maybe you want to you have a video game and you want to look at the total number of sessions for your video game broken out by the dimensions, age and gender. And so analytics are very common, and you see a spectrum where some applications might just have a few use cases for this. And further along the spectrum, you move into what's called a data application. And data applications are very heavy with respect to analytic queries. And in those cases, you'll often see what's called a semantic layer. And I'll talk more about what that is later in the presentation. But a semantic layer is a requirement for any kind of enterprise application that's a data application, and it has to open up data to a really large number of personas in a company or to third parties. And Elide provides that. So first, we're going to talk about the CRUD API. And so I'm going to walk through a quick example of how you would build a model in Elide for a CRUD API. And so as I mentioned earlier, Elide models are just JVM classes. And so this is written in Java. And so this is a book. And this book has a relationship to a set of authors who wrote the book. And there's an ID field, which is the ISBN. And there is an attribute for the title of the book. And this particular model happens to be annotated with JPA annotations, which stands for the Java Persistence API. And so that allows this model to be persisted to a database very simply through an ORM. Now, to expose this particular model in Elide, you would simply have to add the @include annotation. And now it will be available as a web service route that you can communicate with. And the include annotation has certain properties, like you could specify whether or not this model can be accessed from the root of an object entity graph, or whether you can only navigate through it through other entities through their relationships. So once exposed, you may want to secure it, and Elide has a very expressive security DSL. And so you decorate your model with permissions, and there's permissions for read, update, delete, and create. And inside the permission, you put a simple DSL, which is made up of and, or, not, and parenthetic expressions. And you have these little text fragments like book author or admin. And what those map to behind the scenes is those are either mapped to functions, which invoke security checks on the service itself, or they can build a filter predicate that gets pushed down to the database to restrict what is being sent back from the service. Another common thing you want to do with a Elide service is maybe add some custom business rules. And so you can decorate your models with lifecycle hooks. And these are simply functions that get invoked whenever the model is read or manipulated. And so in this case, we're registering a lifecycle hook on book. Whenever the book is created, we're going to invoke the notify marketing class function, which maybe sends an email or talks to a web service or does something else on the back end. And then finally, you can go and query this API either through JSON-API on the left or GraphQL on the right. The other kind of API is the Analytic API. And first, I want to talk a little bit more about a semantic layer. So a lot of times when you're building out an Analytic API, you'll have some kind of database, data mart, data warehouse, and the physical layout of that data is very complicated. There might be hundreds of tables. And all kinds of business rules, and you don't expect or even want your end users to have to deal with that. And so a semantic layer is you want a simple authoritative definition which is curated for consumption by your end clients. And so you're really kind of trying to dumb down the data model and define things once in simple ways. And so a semantic layer creates a logical model that is mapped onto a physical model. The other aspect of semantic layer is that there's often security rules defined for who can access what, and maybe even governance labels that label data for different uses within a company. And then finally, there's documentation, which is basically allows people to read and discover about the data that they can consume. And there's also APIs for navigating that as well. And so a semantic layer typically provides these three functions. And so in Elide, you can build your models in the same way that you do with CRUD by defining Java classes. And so that's certainly one way to do it, and there's special annotations for that. But what I'm going to show you today is something different, which is there's another configuration language that you can build up a semantic layer in Elide. And the reason this particular configuration language is designed for a different persona. And so typically, when you're building out data applications, is that you want to separate the developers from what you call an analyst. An analyst is like a product owner or someone who might curate the semantic layer for the end user. And you don't want that particular persona to have to write code. And so Elide comes bundled with another configuration language for the semantic layer, which is written in HJSON. Now, HJSON stands for human JSON, and it's just like regular JSON, except it relaxes a lot of things and adds some features that make it more friendly for humans to read and write. And for example, you don't have to put commas in, and you don't have to put quotation marks in, and you can add block quotes and comments. And so I'm going to walk you quickly through what the semantic layer might look like with Elide. So in the semantic layer, you'll have tables, and tables will have columns, which I'll talk about in a minute. And so a table might source its data directly from a physical table, like over here, or maybe it sources its data from a specific SQL query or view, like in this bottom example. Or you can also have tables extend other tables in your semantic models. And unlike in the CRUD example, where you have this entity relationship graph of different models that are related to each other, like books and authors, typically for analytic semantic layers, you want to remove the concept of relationship. You want to make everything flat, like tables. Like think Excel. And so you just want to basically expose a flat table. And so, but behind the scenes, you want to be able to map that to a relational physical database where there's lots of links between the underlying physical tables. And so one of the things you put inside your semantic model are joins. And joins basically say, it's a way of saying at query time, if you want to reference a field from another table, add this join to the SQL query that will be executed on the back end. And so the key part of the join is that there's this definition. And you'll see a lot of this in the semantic layers, that a definition is essentially a templated SQL fragment that Elide will use at query time to construct the actual SQL query that will execute against the database. And once you've defined all the joins that you want to reference in your logical table, then you can define columns. And columns consist of measures and dimensions. And again, measures are numeric computations, things like the total number of sessions or maybe the high score in a particular game league. And then dimensions are things like age and gender, things that you want to analyze those measures against. And again, here you'll see that there are these definitions, these templated SQL fragments that define how you compute a measure or dimension for the semantic model. And once you've defined the semantic model, then once again, you can query the same models through the same friendly JSON API or GraphQL APIs. Now I'm going to pause the presentation here for a moment, and we're going to walk through building an example Elide project. And so for this, I'm going to bring up IntelliJ, and there's links for this at the end of the presentation, but we're going to be referencing something called Elide Spring Boot example, which is an example repo that you can download and clone and launch this project. And the Elide documentation also walks you through this as well, and you can also launch this on Heroku. There's a push button deploy to launch this project on Heroku as well. But I'm going to be running this locally on my laptop. And so this is using Spring Boot, which is a popular framework for building web services and job applications. And so there's not a lot in this project. For example, here, this is the application that sort of launches Spring Boot. And this looks just like any other Spring Boot application, if you're familiar with it. So the Elide component are in the models. Again, you're just defining models. And so these three models represent an artifactory where you're maybe building packages and deploying them to an artifactory. And so there's things like groups and products and versions. And these are just simple models with attributes and relationships. So like a group has a reference to a set of products. This particular project also happens to have an HJSON file with some analytic models defined here in HJSON. And it creates a table called downloads. These files over here are again, Spring classes. This is for configuring the security of the application. So I'm not going to walk through those. And the other thing I added to this project is a example integration test, which will launch a test service on your computer, spin one up, and then you can extend this and write full API tests. And so, for example, this test inserts some records into the database, and then it uses Elide comes bundled with a friendly DSL for both JSON API and GraphQL for using rest assured. And so you could build your API request with that DSL and then verify the results are what you expect. So I'm going to, actually, I'm not going to build the project. I'm going to run it. I'm actually running it right now. Just save time. I'm not going to build this project, but I can open up a new browser here. And I'm going to access this on localhost 8080. And this brings up a landing page for this project. So this project comes bundled with some static assets. The first is the Swagger UI for JSON API. And so you can look at the endpoints that are created from the models that we added to the project and run test queries. And you can also go explore GraphQL. GraphQL is another static asset that this project pulls in, and you can run queries in GraphQL. It's kind of like Postman for GraphQL. And so here I've created a simple GraphQL query, and I can run it and see the response. And so again, you can play with this locally or on Heroku, and there's links at the end of the presentation. Okay. So now I'm going to talk a little bit about how Elide is designed and broken up. And so Elide is actually a monorepo, which consists of a lot of submodules. And so the first of these is Elide Core, which consists of all the modeling annotations for building your models. Includes the JSON API parser and the core logic. The reason the JSON API parser is in the core modules is because when Elide first started, GraphQL didn't exist. And so it only supported originally JSON API. And since then, we've added a GraphQL module for the GraphQL parser. And there is a Elide async API, which is often used with analytic queries because analytic queries tend to run for long periods of time. They might run for minutes or hours. And so you want an async API for that. There is a model configuration package, which is essentially the HJSON configuration for the semantic layer. There's Swagger, which builds the Swagger documents for JSON API. And then there's a set of data store modules. Data stores are the way Elide talks to a backend, which could be like a database or a web service or anything that you'd want to add. And so Elide comes bundled with a number of these. First is JPA, which is the primary data store for CRUD API queries. And this basically maps the models to an ORM, something like Hibernate. The next module is the search data store, which is for doing index text search on top of a CRUD store like JPA. Then there's the aggregation store, which is essentially implements all the analytic API queries. There's a multiplex store, is if you want to support multiple stores like the JPA store and the aggregation store together, you can multiplex store will multiplex request the correct store. There's an in-memory store, which is a simple hash map-based implementation. And then finally, a no-op store, which is useful for just implementing simple functions inside your service. And then for test and deploy, Elide comes bundled with a Elide Spring set of modules, a Spring Boot starter, and auto configure for building Spring projects. And then if you don't want to use Spring, there's something called Elide Standalone, which will spin up an embedded Jetty service with JAX-RS endpoints for Elide. And there's a test module which has JSON API GraphQL test DSLs for rest assured tests. And we saw those in the example project that we spun up. Then also there is an integration test module which runs integration tests against all of the CRUD data stores. So to build Elide, you would basically go to the root of the project and run maven clean install first, and that will build all of the submodules in the monorepo and install them locally. And you would do this first, at least once, and then thereafter you can build individual modules by running maven clean install and then giving the particular submodule you want to build. By default, if you run any of the integration tests in your IDE, it will run against the in-memory store. And so if you want to instead switch the integration test to run against a particular store, like the JPA store, you would need to go into your editor and set a property, in this case, the data store harness, and pick the particular harness that corresponds to the store you're testing, and then also set the class path. So this is just something that sometimes trips developers up, and so I'm letting you know if you want to test another store, this is how you do it. And then finally, I just want to walk you through like a very high-level design for Elide, so you're familiar with the code and how it's laid out. And so in this picture, anywhere you see an italics, word in italics, it represents an actual class in Elide. Words that are not in italics represent a concept or group of related classes that implement that concept. So in this diagram, the gray arrows represent the request and response flow through an Elide service. And so at the top, you have the various parsers, JSON-API and GraphQL, and they're responsible for parsing the client requests and converting them into an internal representation for requests. And that's actually made up of these client request objects here on the right. And the other thing the parsers do is they interact with a class called a persistent resource. And the persistent resource wraps every single instance of a model that is managed by Elide. And what the persistence resource does is it invokes all of the security checks whenever a model is read or written to, and it also invokes all the business lifecycle hook functions as well. And then finally, the persistent resource is responsible for reading and writing those models to the underlying persistence layer, which is made up of the data store and data store transaction interfaces. So a data store has two responsibilities. One is to tell Elide about what models it manages, and the other is to create transactions. And the idea with transactions is that each request is marked by a transaction. So when a request starts, a transaction starts. When the request ends, a transaction ends. And the reason this is important is because Elide requests can actually do quite a bit in a single request. And because GraphQL and JSON-API are so powerful, you could read a bunch of books and update a bunch of authors and update a publisher and update an editor and create something and delete something all in a single request. And so if you want to do that atomically, Elide makes sure that all of that happens in the boundaries of a specific transaction. Every data store that Elide talks to is actually wrapped in an in-memory store. This is sort of baked into Elide. And what the in-memory store does is it talks to the underlying store and asks it, can you filter, sort, and paginate this request on your own? And if the answer the store gives is no or maybe, then Elide will actually do that sorting, filtering, and pagination in memory automatically. And so that actually makes it simpler to add new stores that are maybe have less capable backends. And there's also, again, the multiplex store that's responsible for delegating requests to the appropriate underlying persistence backend. On the left-hand side, there are metadata and configuration classes. And so the most important one of these is the entity dictionary. The entity dictionary is responsible at service boot for registering all of the static information about Elide models, like attributes, relationships, security rules, and lifecycle hook bindings. Elide settings is sort of like a set of feature flags for Elide that you can enable and disable, and the Elide object is the starting place where you bootstrap your Elide framework. The type system in Elide, originally Elide models were simply JVM classes, but since then we've added stores that are not necessarily backed by types or like by concrete Java classes, and so we created our own type system for representing Elide models and their attributes and relationships. And then finally, the little modeling section here on the left consists of all of the bits of Elide that go into Elide models. And those include things like annotations, some of the security classes, and also the lifecycle classes. Okay, so now that we've talked about Elide and kind of given a high-level overview of how it's laid out into modules and how it's laid out in its design, if you want to contribute in the hackathon and help the Elide project, you can go to our GitHub repository, and if you search for the label open source -hackathon, it will list all of the tickets that have been marked for the hackathon. And those are actually, we've broken them out into 4 different categories to sort of measure the difficulty of the ticket, starting with PB&J, which is the simplest, which doesn't involve any coding at all. And that could be like a documentation ticket. Canned soup are very simple coding tasks that should be able to be completed in a short amount of time. Consomme on the right is sort of a challenge. And so the hackathon actually does look at not just the number of tickets that are being completed, but also how difficult the ticket is. And so a Consomme ticket would be a challenge, and we would note that. And then everything in between is just soup from scratch. And so for next steps, if you want to read more about Elide, everything I've talked about in this presentation is documented in much more detail at elide.io. And there's 2 primary code repositories for Elide. One is yahoo/Elide, and the other one is the documentation for elide.io is actually broken out at elide-doc. There's 2 starter projects that you can fork and download and The first is the Spring Boot one that we looked at earlier. And also, if you want to use Elide standalone instead of Spring, there's also an example project that's the exact same thing for that container. If you click on the link in this presentation, it'll take you to Elide categorized tickets directly. And I also wanted to call out one other thing, which is Yavin. Now, Yavin is another project that we're launching at Yahoo, which is a framework for rapidly building custom applications. So this is much more front-end focused, but it uses Elide. And so if you're interested in looking at a real-world example of Elide that's based on Kotlin instead of Java, you could check out the Yavin project. Thank you, everyone, for listening to our overview of the Elide framework. If you are interested in participating in the Yahoo Hack Together Hackathon, or perhaps helping us build Elide, there will be some follow-up sessions and office hours in the months of March. And I just want to thank you once again, and I'm looking forward to seeing your contributions.